All right, so sorry I got cut off on the last video. Let's finish up these examples. So number 5 and 6, okay, you may notice they aren't super easy to graph, right? Because I can't tell what the y-intercept and the slope are, right? These look like they're in almost standard form, okay, but just with inequalities. So we need to arrange them into slope-intercept form with just inequalities. So to do that, we're gonna go to a blank page and do a little math. So I have 5x minus 3y is less than or equal to negative 15, okay? Now, we want to arrange this into it so it looks like slope-intercept form. So to do that, we will need to solve for y. So I want the y by itself on the left side. So to do that, we're going to subtract 5x from the left. What I do to one side, I do to the other. Draw the arrow, draw the line. 5x minus 5x cancels. Those are a 0 pair. So I have negative 3y is less than or equal to negative 5x minus 15. Remember, I just like to bring the variable in the front because it makes it a little easier at the end. Then, last step to get the y by itself, I'm going to divide by negative 3, right? What I do to one side, I do to everything on the other side. So I divide that term by negative 3, this term by negative 3, okay? Now, here is the fun part. Negative 3y divided by negative 3 gives me a value of 1y. We know that, okay? But here, since I divided by a negative, okay, my inequality must flip. So instead of being less than or equal to, it now becomes greater than or equal to. That is a big thing, okay? Make sure y'all remember that. Whenever you divide by a negative with the inequality, flip it, okay? Now we can do all the rest of our division. Negative 5x divided by negative 3. Two negatives make a positive 5/3 x. Negative 15 divided by negative 3 gives me a positive 5. So now I have the inequality y is greater than or equal to 5/3 x plus 5. So I'm going to write that down. So I can scratch this out, and we can use y is greater than or equal to 5/3 x plus 5, okay? So now, using that inequality, I can tell that my line is going to be solid because it has an equal to, and my shading is going to be above because it is greater than or equal to, okay? And then we can plot our points, or we can draw that line. So my y-intercept is 5, so I put that right there, okay? And my slope is 5/3, so I can go up 5 to the right 3. But if we look, if I go up 5 to the right 3, that would be completely off the page. So I have to go backwards. So I'm going to go down 5 to the left 3. Okay, so I'm going to go down 1, 2, 3, 4, 5. 1, 2, 3. And I'm going to do it again. 1, 2, 3, 4, 5. 1, 2, 3. Right there. Okay, so I got 3 points. That's good enough. It's going to be a solid line, so I'm going to try to connect the dots as best as possible. That was pretty good. And we shade above. So I'm going to shade starting up here and shade down a little bit. Just like that. Okay? Same thing. We're going to plot some points. So we'll plot the point 0, 5. That's right up here. It's already kind of plotted for me. The point negative 4, 1. There we go. Now it's working. Negative 4, 1. And 1, negative 3. Way over here. Okay? So 0, 5. That's right on that solid line, right? So if it's on a solid line, that means yes, it is a solution, okay? Negative 4, 1, right in there, clearly in the shaded, yes, that is also a solution. And then 1, negative 3, all by itself, no shaded, not on a line, no, not a solution, okay? And now we're on to our last example. Again, it is already not in a form that's easily graphable, so we need to grab a piece of paper, do some math. So I have x minus y greater than 2, and we want to solve for y, so we can graph it easily. So I need to move the x, so I subtract x from the left. What I do to one side, I do to the other. X minus x cancels, 0 pair. I have negative y greater than negative x plus 2. Again, I just move the variable to the front, same thing. And then right? I want the y by itself. This is a little hard to remember. So to get the y to be positive, we're actually going to divide by -1. What I do to one side, I still do to each term on the right side, okay? So now, again, the fun part, -y divided by -1 gives me positive y, okay? Since I divided by that negative, I still must flip that inequality. So that becomes a less than. Negative x divided by -1 becomes a positive x, and 2 divided by -1 becomes a -2. So I get the inequality, y is less than x minus 2. And we can go use that, so we can scratch this one out, and use y is less than x minus 2, okay? And we just go from here, right? The line, since I have an inequality without the equal to, that means it is going to be dotted. And since it's a less than, it's going to be shading below, okay? So we're going to go ahead and graph our y-intercept, which is -2. My slope is 1. Remember, there's an imaginary 1 in front of the x, so I just go up 1 over 1 every single time. So basically just hit all the diagonals. I can do the same thing going back. And it's dotted, so I can kind of just leave it like that. I just got a bunch of dots, so it works out. And I'm going to be shading below. So we'll shade down here, get a little bigger, and about right there. Cool. And lastly, plot some points. See what we get. So I want to plot the points 1, 2, right there. 4, 2, right there. And -2, -5, right down there. Okay? Now, 1, 2, again, this is the point right here. It's not in any shading. It's not on any line. That is obviously not a solution. No. 4, 2, on the other hand, is on that line, right? It's on that dotted line. But remember, if a point lies on the dotted line, no, not a solution, okay? And -2, -5, well, that's clearly in the solid. In the shaded. So that is yes, solution, okay? So that's just a quick little run through, not super quick, but kind of quick little run through about graphing linear inequalities, okay? Next is we're going to learn to graph systems of inequalities, okay? But if y'all have any questions right now, feel free to ask your teacher and we'll help y'all out, okay? Y'all have a great day. See y'all in the next video.